Capstone Festival of the School of Computing and Design at CSUMB. We haven't had a fall capstone for a long, long time because we only have one capstone. We have been running one capstone in the spring for at least 4 years or 5 years. And this year we have a small capstone class. This is why the audience not as many as you will see in the spring. But thank you for being here. As you probably all know, capstone class is created to help our students transition from college to career. Okay? So the final capstone project often reflects how well our students learn in the major. Not only that, but also often reflects how well they work in teams and work with clients. And we have 24 students graduating this fall, and they worked on 8 industry-driven real-world projects. Because this industry-driven, we always have an industry mentor for them. And it's very critical, and we highly value our partnership with industries. So I would like to acknowledge their contribution, their time, and all the energy and effort put into mentoring our students. So industry partners and mentors, if you are here, can you please rise and be recognized? Thank you. We know we have more, and some of them couldn't make it today, so they came last week, right, on Friday. And throughout the process and our students' learning, there are a lot of people who contributed to the success. I would like to recognize those people who spend days and nights and really work with our students to help you get here. That's our faculty. If you are our faculty as SCD, please rise and be recognized. I see that our dean is here as well, Dean Andrew Lawson. Thank you for being here to support us. And as I mentioned, today we have 8 programs. And the order of the program, if you look at the program brochure, we placed a bunch at the last row. There is no particular order. We picked 3. Those are, we thought, representative of the entire spectrum of the projects, the type of projects we have. But it's very difficult for faculty to judge, which one is better than the other, right? We have certain sense, but they are all different. Therefore, the order does not really imply anything particular. And I think I'm forgetting a couple other things. And friend and family, we see some. Thank you very much for being here to support our students, and also throughout their study in their program when they're going through the computer science degree program. And another group, of course, I would like to really congratulate is our students, all 24 of them. You worked really hard, and you should be proud and really happy that you are here to present your final project. And we look forward to seeing your project. Sattar Narayanan, who is the instructor of this class, who really helped to put this class together and got the projects and helped identify the mentors. So I really want to thank him and recognize his contribution. Thank you. So without further ado, let's begin the presentations. First team.
Okay, so we are Linkality. My name is Nathaniel Davidson.
My name is Cody Boaz.
I'm Yantis.
Imagine you're in a convention. A convention can be loud, it can be noisy, it can be chaotic. You can get lost, you can lose your friends. So these are some of the problems that can occur at a convention. So you could have scheduling issues. What's going on in what room? What is happening for an event? Like, what's the timing? Where are my important guests? Where is the low trafficked areas? Which booths aren't getting that much attention? Which ones are getting more? So you can, our solution to this is to actually track the user or the guests' locations, and then to keep a hash, like a history of each one of their locations. And then throughout the time, we can create a heat map indicating which booths were visited more often. We can point out the points of interest, so which areas were the greatest for guests' interest, and which areas had bottlenecks, which areas you can improve the flow. So this is our full stack. We use Android and iOS apps that you can actually download right now on your phones. We have a node server. We have so on the right-hand side, you can see this is our RFID implementation. On the left-hand side is our beacon implementation. And then we have a database.
Yes, and so you'll probably all notice that you have a name tag. Hopefully you all do. If you look on the back of that, you'll see a little sticker with a color and an animal. And that is actually the RFID tag that we use to track where everyone goes in the convention here. And in our app, we actually have a system where if you search for the color and the animal of your friend, it'll tell you where they are. So if you get separated, if you end up on one side of Comic-Con and they're on the other, you'll know where they are and you can meet in the middle. And also, as Nathaniel was saying, we generate a heat map of what areas were most popular. Another application that might be in the future as we build historical data, we could use that to suggest other events that people who like say at Comic-Con, if you were at like the X-Men panel, you might suggest you like the Star Trek panel. So you could say, hey, that's starting in 15 minutes.
That's right. So our app is basically a festival brochure. Our app, as Nathaniel has mentioned, is available in the iOS and Android market. Users can simply browse through our app to get festival information such as scheduling, building map, and team information. And for users who are not familiar with our building, we also have iBeacons set up in every room. If a user comes within contact of an iBeacon, then a notification will be pushed to their phone. For example, if you're standing in room 104, it'll say, you're in room 104, would you like to see the schedule for room 104? If the user says yes, it'll be presented with the schedule for that room. In addition to the brochure feature, we also have a Find Your Friends feature. On the back of your name tags, as Eddie's mentioned, is a secret identifier. If you type that into the Find Your Friends feature on our app, it will show their previous known location. For this event, it's kind of small. If you lose somebody, it's probably pretty easy to find them. But if you're at a massive convention or festival, then that could be very useful to find a lost friend or a child.
So this is our web interface. We can add beacons. We can create RFID readers, which are the antennas that you see outside. And then we can associate each one of those to a specific reference.
So the technology that we used to accomplish our project was MongoDB, RFID tags and readers, iBeacons, AMTech, Modulus, and Node.js, as well as NativeScript.
Okay, so basically conventions do have problems with tracking exact attendance numbers and making sure everyone sees everything. So our system helps that by by providing information to people about events that they might like to see, and new events or
So we'd like to acknowledge our mentor Eduardo and Sattar, our Capstone teacher. They have provided a bunch of help for us, and they've also sacrificed a lot of time. So we'd like to say thank you to both of them. And if you like to track either of them, their secret identifiers are listed here.
Hi everyone, how's it going? My name is Bilal.
My name is Juan.
My name is Leo. And we worked on a project called STOQS, where we worked with a company called Daugherty, it stands for Monterey Bay Aquarium Research Institute, and we helped them implement the feature into their STOQS program that they have.
Right now we're going to present our Capstone project called STOQS Virtual Reality. We're going to present our Capstone called STOQS Virtual Reality. So STOQS stands for Spatial Temporal Oceanographic Query System and was developed by Embari. Embari uses STOQS to display all the data collected from the ocean to make it available for any researcher through any web browser. Embari stands for Monterey Bay Aquarium Research Institute, and what they do is that they focus on the research of the ocean from the surface to the seafloor to have a much better understanding and complexity of the ocean. As you can see here in the map, here are some examples where they have done some research and also where Embari is located at. For our project objective, we were assigned to work on the STOQS GitHub issue 369, which was to implement a Google Cardboard web VR to display the 3D terrain scenes.
Okay, so what is virtual reality? Virtual reality is putting on or being immersed in a scene that you're not in. So essentially what you do is you take a headset similar to this and you open it up, set it up, and you can stick your phone in here, okay? Stick your phone in here, close it on it, and you look inside. So what happens is you see an image, and you see actually two images, and when you move around, move your head around like this, the image will move and make you feel as if you're in that place. So Google Cardboard is basically something like this. It's just a headset made out of cardboard. Google made this to make virtual reality easy for everyone to access. So something like this would cost you maybe $3 or $4. If you want a really nice one, it's made out of plastic, maybe $15 or $20. So it's easy to access. Anybody can use virtual reality.
For our approach, we started by making a fork of the STOQS repository. We use VirtualBox and background to run STOQS in our virtual machines. We use the X3 DOM framework to display 3D scenes into a web browser. We use HTML5 and JavaScript for our implementation. We commit regularly on GitHub, and we submitted several pull requests into the STOQS master repository. This diagram illustrates all the tools that we use and how we use them during our implementation process. The diagram also illustrates the back and forth activity between our fork repository and the STOQS master repository. We were constantly pushing changes into our fork repository and pulling changes in from the STOQS master repository. For our results, we implemented a functional Google Cardboard web VR mod that is able to rotate 3D scenes using a phone's rotation and orientation. This web VR mode is compatible with Safari and Firefox. This is a link to a demo.
Mention the hackathon.
Yes.
So we basically worked on this, we got it working, and then we entered into a hackathon. I'm not sure if any of you are familiar with the San Francisco Virtual Reality Hackathon. It's one of the bigger hackathons geared towards virtual reality. We entered it in 2 categories and we won in 1. We won the best X3D project, and X3D is like a framework. It's basically like a library of code that helps you create these scenes. So you don't have to write everything from scratch.
As you can see here is how it would look on the web browser, and when we go to full screen, this is how it would look.
The short little GIF that shows you kind of how it works. So when you look around, you can see that this scene is rotating. And this works in the web browser. So as long as you have Safari or Firefox on your phone, you can load it up, go to the site, and it'll work on your phone. So for the future, we'll be able to add many more features to it. Right now you can just stand in one place and look around, but in the future you should be able to maybe make a wide open space and walk around in the scene. So if you're at one spot, you can go to another spot and see what's up over there. And we also want to be able to make sure that users can pick where they want to be placed in the scene. So if they want to, be on one side of it or the other side of it, it's up to them. They can look anywhere they want. And being an ocean researcher, it really helps to be in the scene yourself, so you know how it's going. For our acknowledgements, we really want to thank everyone for being here. Without you guys, we wouldn't really have anything to present. And I really want to thank all the computer science faculty for giving us all the knowledge that we have to do this. I want to thank Professor Sattar for hooking us up with Embari. We want to thank our mentor especially, who helped us a lot, Mike McCann. We learned a lot from him. He's from Embari, and hopefully we can get some more work with him in the future.
Hello everyone, we are
Quinn.
Anthony.
and Kevin, and we'd like to welcome you to the third law. So the third law is a procedurally generated magical research and experimentation game. But what is procedural generation? To understand it, procedural generation is the use of computer algorithms and mathematical algorithms to generate random content. This can be anything from levels, worlds, bosses, weapons, anything. So a good example of this is Minecraft. In Minecraft, all the blocks you see on screen are placed according to some code somewhere that the developer has made. And now while procedural generation has existed since the dawn of video games, it really hasn't been able to create truly meaningful content. For example, the game No Man's Sky was often criticized because the game felt kind of static and unfriendly to players. So our goal with the third law was to create a game where procedural generation was brought to the next level, where even the gameplay was determined by algorithms. So with the third law, everything, every physical law is randomly generated. Heat might control gravity, light might control size, density might control color. And it's up to the player, the world's first scientist, to use empirical experimentation techniques to figure out those laws, use them to build contraptions to solve problems.
So our approach for making this game was to use CryEngine. Not only because Crytek, who makes CryEngine, sponsors our school, but also because you can get really pretty graphics really quickly. So you can see in the screenshot here, that's like a really gorgeous looking screen. So we knew we can get results very quickly with it. One problem with picking CryEngine was that no one's used CryEngine, at least not at this school, so we'd have to figure everything out for ourselves. So the design was to first make the backbone code, the code that would decide every single playthrough, how exactly do properties interact with each other? How is it unique every single time that you play it? That's the backbone code, which I'll show you a visual representation of in the next slide. Also, we had to use the flow graphs that CryEngine provides with us, which is a great way for scripters or design people to actually write their own code. It's a less intensive, less programming approach to being able to actually program objects. And then we also had to link all the game objects to a Lua script that would work through these flow graphs. So that's the design aspect. The backbone code itself is basically a gigantic data structure that's created every single time the game is made. The number of tiers is procedurally decided, and also the length of how many properties are inside of each one of these tiers is also decided. These links are also procedurally decided, so if you have some property here, maybe it's called Moitenstalk as a name generator, and you add 5 Moitenstalk to an object, this would trickle up and eventually add a certain amount of light or weight or size or something that's actually visibly representable to the object.
So now we'd like to have a short presentation of some gameplay footage to show you what we've accomplished. So going forward, we would like to improve some of the interaction we have with the world. Things like generating quest lines for the players to go down, ruins for them to explore, maybe integrating some kind of rudimentary combat system even. And we'd also like to refine some of our algorithms. They're good, but they're not quite as good as they could be. Again, increasing things like, or improving things like our NPCs, getting them to interact with the players on a more believable and natural way. And we would like to thank Crytek and the VR First Lab for providing all of our hardware and software and stuff that we use to create the game, and the Game Research Lab here at CSUMB for supporting us throughout the project.
Alright, hello everyone. My name is David Espinoza.
My name is Daniel Gopar.
One of our team members is here. We work with SSCS, which is Service Stations Computer Systems, based right here out of Salinas. And what we did was the inventory scanning app.
So one thing I quickly want to mention is that our team member that's not here, he had a family emergency, that's why he couldn't make it. It's not that he didn't want to. I just want to make that clear.
So what SSCS does is help service stations, gas stations, ensure and maximize their profitability. What our app aims to do is just take their inventory scanning process from a more conventional manual method to an electronic method. So in essence, it's scanning everything rather than having to check everything manually, and create electronic record of it.
So some of the project objectives that we had was to be able to scan different types of barcodes. So if you're like me, you believe that there was only one type of barcode, right? There's 13 characters long or whatever, but we found out that there's basically a good amount of different types of barcodes. Anything from small from 8 characters long all the way to 13 or 15 characters long. So we needed something to be able to parse that out. So the user will be able to scan it without having any issues. So also, when the user scans something, we should be able to search the database if there was anything already there of that particular barcode. For example, we scan a Pepsi, and we scan a Pepsi later on within the scan. It should auto-populate it with, for example, the unit cost that it is. So that way, it saves the user's time. Also, look up the product information. And also, when we auto-populate, the first time that we create a scan, we'll still give the user a chance to fix anything. For example, if they want to add any comments towards that product or anything else. And of course, synchronize it with the database that already exists with SSCS. So our approach first was to obtain the technical requirements for that mentor. And that, of course, was figure out the scope and how much work we should put into it, how big the project is. Next, design the UI mockups. We made the UI mockups with XML through Android Studio. So we actually made the screens in code instead of a mockup tool that you find online. And also, and after that, so we got all that squared away. We downloaded the database from SSCS servers. So each, for example, each customer can have multiple stores, not just one. So depending on which store they wanted, we would ask the user, hey, do you want to download this database right now or later, things like that. Also, we create the UI flow and the forms, so that way the user can enter the data, scan the barcode, and then populate, just scan. So our solution design is basically we use Android Studio for the coding. So anything related to Android, we use the IDE. We use Espresso for functional tests, so integrated testing as well. We use Butternut for dependency injection. We use Retrofit for the asynchronous task for downloading the databases onto the phone and storing them. And the library with the Zebra one, I think it's called Zing, or Zing, I don't know, it didn't have a pronunciation on the README and the repo. So basically that it's a third-party library that helps with the scanning. So that did a lot of heavy lifting for us. That way we didn't have to spend the whole semester creating something to read barcodes. And of course, JUnit is for unit testing the Java code.
picking the store where you want to perform a scan, and some of the options such as getting the data from the server that we use to check against, update, upload that data, physical inventory, which I'll get into a little later. So some of the things that we will do in the future is pair a Bluetooth enabled scanner to just make the scans that much faster and easier. Be able to go back and edit a scan. People make mistakes, so go back and tweak things that update items.
And the third one is that we want to be able to create different lists, so invoices. So right now the way we have it is when you create a scan, you'll continually save it to that list unless you start another one. So there's no way of separating each one. So that's another thing that we need to work on. Yeah. So for acknowledgements, we'd like to thank Mike Cook, our mentor. I don't think he's here. Satya, of course, and SSCS for allowing us to work on the project.
Hello, I'm Matt Johnson. I'm Brian Zimmerman.
I'm Josh Shallow.
And I'm Tim Perry. For our Capstone, we developed a 2D game engine framework. Our program will take in a fully designed level and output a playable game. Our mentor is Dr. Christian Eckhart. He is a teacher here at CSUMB. And he is the sole developer of ECModel. It's a program that students can use to design levels and model. He also teaches CST 320, Intro to Digital Games. In that class, students will learn DirectX, which is a complex graphics framework, and it has a very steep learning curve. DirectX is a very common framework, and it's very popular in the game industry today. It's coded in C++, which me and my colleagues are familiar with and very comfortable with.
So let's talk about what game engine or framework is. A framework is essentially a collection of existing code that programmers can use to build an application. And that's beneficial because you don't want to reinvent the wheel, you want to start from scratch, or you don't want to start from scratch each time. In the context of games, you might hear the term game engine, which is essentially a framework for building games. And it'll consist of a framework like a graphics framework, such as DirectX. You might have a physics framework, an input framework, and then you'll have your game logic to build a complete game. And this is so game programmers can just jump straight into building their game rather than building like the drawing capabilities that DirectX would provide or the physics that a physics framework might provide. So let's talk about the project objectives. Our project objectives primarily, we needed an engine that used DirectX and simultaneously ease the barrier of entry into DirectX, because DirectX is notoriously hard to break into. It's a very difficult framework to just pick up and run with. We also needed a framework that had the ability to load levels in from ECModel, which, as Tim mentioned, it's the software designed by our mentor, Dr. Eckhart. And then lastly, we needed basic core functionalities that most marketable game engines will have. So as you saw on the last slide, that includes physics input, but it also could include sound, it could include animations. So that's kind of what we're working with. So for our approach, we had to decide what the basic needs for the game engine were going to be. We needed level serialization and deserialization, which is taking the level from ECModel, converting it into a file that we could read, and then taking that file and putting it into a game world. We also needed a basic game object class, which all other classes would derive from, and including colliders. Colliders use a point in triangle function to determine if a point is inside of another object. We use triangles because DirectX uses triangles to draw everything. We also created or implemented input for both keyboard and mouse and game pads. We also provided support for audio to create sound effects on triggers and background music.
So our solution design, we talked to our mentor, Dr. Eckhart, and we discovered that we needed all of those things in order to create the basic game framework. Once we got started there, we started designing our hierarchy for the class. So we created the game object, and then we decided what we wanted the framework to look like. Once we got started coding, we realized that it's not going to look like what we wanted it to look like. So we had to adopt an agile-based approach, which means you change your code in order to adapt to the situations.
Alright, so a couple of the challenges that we ran into. First of all, the beginning challenge we had were dealing with ECK model. Like we mentioned, Dr. Eckhart's software we used. Basically, like learning new software, right, it's always going to be difficult, so we had to get some help from him as we went since he actually designed the software. And then we also, like Josh mentioned, we wanted to parse the levels using XML, which is so it could be more universal for other software modeling programs as well. So we had to change ECK model so that it would actually make levels in XML files instead of just simple text files. And then we also had to change our engine so that it would read in an XML file. And then some other challenges that we had, like Josh mentioned, were changing up the hierarchy as we went. So instead of just having a game object, we would have moving objects and stationary objects. And then we had colliders that had to belong to the game objects, for example. The last major challenge that we ran into was dealing with animations. So in 2D games, animations are pretty much always done with sprite sheets, which are basically it'll have an animation across a row or a column. And so we wanted to implement animation states. So let's say if you're pressing right, your guy's going to move to the right, or pressing left, he's going to move to the left. So here's a quick video, basically demonstrating designing a level in ECK model in the first half of it. So we're making just a very simple level with some platforms and some colliders. And then it's going to create the XML file like I mentioned. And then in the end, you'll see we put it into our engine, and we have a basic level where we can have our player with some animations, and we can run it on the platforms. So for the future work, one thing we want to implement, or we want future students to implement, is to improve on the physics. So we basically just have very basic physics right now, but if we could add bounciness or friction to the colliders, that would be very nice, and it's something that's involved in lots of other game engines. And we also would like full ECK model integration. So right now we basically have game objects, colliders, and lights, very basic things like that. So you could add things such as enemy spawn points that could be exported in the XML, as well as objectives such as like ending of levels, for example. And then also some more complex handling for animation. So like I mentioned before, animation is usually when the sprite sheet is across a row or a column, but sometimes it's not just one animation on one row. Sometimes it'll go to the next row, or like even just halfway through the next row, and then another animation will continue after that. But our engine only handles like a single row or a single column. And then we can also add multiple types of sprite sheets so that the user won't have to do as much changing of parameters, because right now they kind of have to manually decide which row is for which animation state. And then lastly, we want to mention that our code will be open source and will be available on GitHub for a future collaboration. So some acknowledgements people want to acknowledge are Dr. Eckhart for all of his help and for giving us an awesome capstone to work on. Satya for helping us work as a team and just pushing us forward throughout the class. And then Morgan Johnson, he's the TA for CST 320, and he's like just a genius basically. He helped us a few times. He's a really helpful guy and helped us a lot.
Alright, good morning everyone. We would like to thank everyone for coming today. So my name is Mateo. Sixtos. I'm a computer science major. I'm a software engineer. And this is
Hi, my name is Peter Moung. I'm also a computer science major with an emphasis in software engineering as well.
So our project is the CIG's Android mobile app reboot.
This will be navigation throughout our presentation. We have the background project objective and the dashboard bullet points that you can probably read to.
So a little background about it. So we're working with the Capital Insurance Group company. It was founded in the year of 1898. And some background of the App Store of the app is that it has between 1,000 to 5,000 downloads. This makes up like around 5% of total customers that they have. So we need to get that up the highest percentage-wise. And Google Play Store is rating the app an average of a 3.5. So we want a minimum of 4.0. So And the last update that it had was on August 27, 2014. And the tool that we used with this app was Android Studio. It requires an Android version of a 2.2 or higher. And we're using the API 18, which is considered Jelly. So CIG's version. So there's 3 screenshots of the app right here. And as you can tell, there's 3 issues with this. The first one is that UI is outdated. It's been outdated since August 27, 2014. There's a lot of redundancy. So as you can tell, there's the middle picture is the main page. And then once you click on the first button that says Manage My Policy, it literally takes you to the same page. The only difference is that it gives you a navigation at the bottom. So we need to get rid of this redundancy. Another issue with this is that it's only 5% of app usage, which meaning that only 5% of customers are using this app. Not only that, but in the UI you could tell that it's unappended to the app.
So our project objective is to improve the usage of this app by 10%. We're going to do that by redesigning the user interface and just create a more visually elegant design for the user experience.
So our approach to this. Our approach for this is to first renovate the user interface, the UI, how it looks, how it feels. Step 2 is to implement the functionality of the new redesigned UI. So the user interface, so this includes the navigation at the bottom, at the top, the data that we input dynamically, and the buttons that are in the frame. So, and then step 4, and the last step would be to, step 3, I'm sorry, is to implement an API to contact the nearest tow truck if necessary. Let's say you're stranded in the middle of nowhere, and you need to contact something, the app will do this for you. And then also, the final step would be to append a registration process so that any user could apply to the company or register to the company. So our results. This is going to be the deployment of 2017. So this is how it looks. 3 things that you can notice is it's more modern. It's eye-opening, and the redundancy is over. So as soon as you log into a page, it takes you to the policy page, which contains the navigation at the bottom. We have the tabs on the top, and then we have the framework in the middle. So something that it has the same functionality as the other app. The only difference is that how it looks. It's simple. As you can tell from the other previous pictures, the tabs are aligned from top to bottom, and it's harder to click on the buttons. Let's say you want to click the top one, by accident, and you click on the second one, it's annoying. So now it's next to each other, so if you do decide to click on top of it, it's still going to click this one, not the top.
Feature work will be implementing an online payment feature through the app, because traditionally one has to turn on your computer or open up your phone, head to the company's website and log in with your credentials and a 15-character password, and then you have to maybe enter your credit card information if or it's already saved, and then pay. Or you can just log into your app that's already signed in and just tap the button to pay. And the second thing we're going to implement for the feature is the agent locator. So it's pretty self-explanatory. You locate your nearest agent and with the tap of a button as well. Magic.
So we would like to end this presentation by acknowledging our mentors. We'd like to give a special thanks to our product owner, John Halberstadt, who gave us the opportunity to work with him in this project. Another person that we would like to thank is the project manager, Jimmy Skidamore, who is a liaison between the product owner and us.
And we also like to thank Mahendra K. Gopar. He was a software developer at CIG, and this invisible text. We also like to thank our instructor, Professor Sattar.
We work on Otter, nothing hotter. So, my name is Miguel Lozoya. I'm a computer science student here, studying software engineering.
My name is Mariela, Ceja. I'm studying computer science.
And so, what was our motivation for our project? So by 2019, it said that more than 80% of the internet content will be in video. And if you're like me and you have a problem that you can't fix, sometimes you'll either Google it or look somewhere on the web for it. And many times we'll find that in either, maybe in the form of a video. But once you figure out that issue and you go back to it, or you have it again, you might wonder, well, where did I find it? And maybe the process that you took to get there was kind of difficult, and next time you Google it, of course, if it's in a video and and you learned it from an audio, you won't be able to find that, so it's unindexed. So your Google searches will be in vain. So our solution was to create a web application that can take video and give back the transcription. So we wanted to do this using, here it is, user gives video, and we're going to use, we used Azure's Media Indexer. This is created by Microsoft to provide the functionality to transcribe any video or audio and be able to provide the text format for us. So our solution was to use GitHub to manage our version control. So all our code is up on GitHub right now, and it is open for anyone to see. We used Trello to kind of manage our user stories. So what needed to be done was all handled on Trello to kind of manage that. Whenever we run into hiccups, we could reprioritize what we're going to do. The backend is done in C#. Mainly, we use ASP.NET, which is Microsoft's model view controller approach to making websites. And so controllers are done in C#. The front end, of course, is done in HTML and JavaScript. And Azure also provides kind of like the cloud platform for us to host our website. It also holds our database, which is done in a blob. And then it also has access to Azure's Media Index.
So some of the challenges that we were faced with were working with ASP.NET framework, which we both were not familiar with. Another thing was we were using Visual Studio, which of course before was mostly for Windows. Just recently they got a version out for Mac and Linux, which Miguel was working on Linux, I was working off of Mac. And we were having challenges with the Azure Media Indexer in the early stages. The deliverables for this project, we were basically, we finished the website with the login system, video caption synchronization, where the captions are highlighted. There was a notification system when the media is transcribed because it takes about 5 to 10 minutes when you get a transcription from a video. And we have the media indexer, which jumps to video to selected text. We also have the documentation for the project. This is basically a model of what our project will look like, where the media indexer transcribes the text, and we link the text to the video so that it shows what it's saying. Now moving forward, one of the things we see for this project is probably integrating the YouTube, so that when you see on YouTube the video, also in the below you could see the whole transcription text, and then it would automatically upload it to YouTube.
Yeah, I found it. You think I've done this? Yeah, right.
Hello everyone, we are data analytics and data and visualization team. We are working with Capstone Insurance Group, and this is our team. My name is Arash. Stefan. George.
So the savvy business person is aware, informed, and prepared, and that's all to say that he has access, or she has access to valuable and relevant data. But if data isn't analyzed and organized in a way that makes it, usable, it can be deceptive and useless. So our goal is to provide data analytics with machine learning prediction and data visualization for our partner company, Capstone Insurance Group.
This is the technology that we use, RStudio, for the data programming, Shining for the visualization, For communicating with CIG, we use Confluence, and within the university we use Trello, and we use Jira software on the project management side, and Oracle database for the data. Our approach to visualization was to generate, for CIG, a product that would be able to visualize the data, and we had a lot of data to visualize, so we wanted to make it user-friendly for the company, and also for them to be able to predict the future with our visualization.
We're gonna show a short video on the dashboard that we have created for CIG. And the dashboard, we're displaying graph for two of the agencies that we analyze. One is BH and the other one is Harley. As you can see, we try to make it user-friendly as we could, as well very intuitive for CIG employees. And each one of those graphs, we're displaying the revenue and the accounts for the new contracts and the cancel contracts. This is now a snapshot of some of the graphs that we're displaying in the dashboard. For this one specifically is for the BH and which we're showing how this agency is doing the revenue and the accounts for the new contracts and the cancel contracts. This is the same thing as the other one, but this one we're showing that information for the other agency, which is Harley. And these graphs, we're displaying the revenue distribution for each of the business lines for each of those agencies. As you can tell, we have assigned a unique color for each of the business lines, so the business people or all the employees at CIG can recognize how those agencies are doing.
So our approach to prediction is that we looked at each agency and we predict their revenue. We predict the revenue for each agency, and we use auto regression, and which uses legacy value of an attribute to predict itself. And for improving our model, we use moving average decomposition. This is one of the prediction results that we produced. We created a testing framework that runs the code as if the agency is running it every day, and all the red points on the graph represents it's predicted 30 days ahead of time, and as you can see, the mean absolute percentage error or make is less than 1%, which is pretty good, and our average error is about $120,000.
This is the same testing framework being run on our other agency, Hartley, and as you see, it looks pretty close, but this is over 12, I think 14 years actually. So some of these differences are actually pretty significant. Here we have an error of 2.24%. So this agency was a little bit more. So we decided to do a little bit of something else to improve that error. So we did a decomposition, and what we did is a moving average decomposition. And what that basically is that we take, in this case, we took the last 90 days, and every point on, say, like this graph right here, every point will represent an average of the previous 90 days. So that would sort of represent the general trend. So what we did is we subtracted that from the original data and came up with this static data right here. And the idea we had was that we were going to run our prediction model on both the static data and the moving average data, then combine them to get a better prediction. So this is the combined prediction right here. It looks very close to the same as the other one, but it does operate slightly better with a 1.97 error.
So as future work, we can extend the same model to other agencies that CIG work with, and they can get the same result for the other agencies. We can use external data sets to have better predictions, like better data or economic data. And also, we can use different regression algorithms. Right now, we are using linear regression. And also, also on the visualization part, we can have real-time and dynamic visualization for better use. We want to acknowledge our mentors, Juan and Sasi. They helped us a lot throughout this project. And we also want to thank Dr. Franz and Sattar for their support.
As you know that the university only have once a year commencement in May. So even if you're graduating now, we really hope that you come back in May and walk during the commencement. And we would really love to see you there. And as a teacher, if you're a teacher, you know that it becomes quite emotional to let you go after you hovered you around for several years here, right? So I would like to provide a few, probably two advice. The first one is that being in the computer science is a very challenging, computer science is a challenging profession, right? You have to learn all the time. And your professors here, we would like to believe that we equipped with you the fundamental skills and knowledge necessary for lifelong learning. So you need to have the mentality that you are going to learn all the time. And your capstone, through your capstone, you also notice that that's the case, right? A number of you learn new software, new apps, new things. And that's going to be your daily life moving forward. So be prepared. You cannot be lazy, okay? This is a hard-working profession. And you should be proud of doing that. Second advice is really the attitude, okay? Keep your positive attitude. You will have ups and downs in your profession. It does not matter, that's how life works. But it's really important to keep yourself reminded that positive attitude will get you where you want to be. Okay? Is there anyone else want to say something?
There's the job and there's your career. The only person who really cares about your career is yourself. So think that you have to do something for your employee, but at the end of the day, you have to manage to stay in this business for until you retire, right? So you have to keep learning and you have to keep planning your career as it moves forward. It's not as easy, it's complicated.
Thank you, Eduardo. Dr. Jan?
Hello everybody, congratulations everybody, and what I'm thinking is I'm a computer scientist for many years, but my one comment is that we work for not computer, we work for human being, so don't forget about this. Sometimes I feel like students so love software, they spend a lot of time, but don't forget about this. We work for human being, so love should be the always top priority, no matter what. Okay? Thank you, everybody.
Anyone else?
I'll just add to what Dr. Jun said, and many times I think about what are the priorities, right? Family, health, and then all of this, right? A lot of times we forget that and we kind of focus on job and kind of career and get comfort. I do this all the time. I still do it, even though I say this, right? So it's sometimes work kind of takes you away that way. Remember, family is important, and health. Until your back starts hurting every time you get up in the morning, you don't appreciate like how good it was to have it back without a pain. So appreciate health when you have it, and appreciate it.
Yeah, I know that Satya called me last night too. Gosh, I've been so busy. I forgot to pay my mom's electric bill. He does not have power now, right? So that's how things get in the way, right? And this is exactly the example we want to remind you, okay? Priority. You want to say something?
Yeah.
Your mom.
Go ahead.
This is probably the last time that I can say anything that matters, that anyone will listen to. So I just want to thank all of our faculty. I think all of us would agree, all of us students would agree that we have great teachers here, and they do everything that they can to help us and make sure we get everything out of it. And I just can't thank you guys enough. Like, we're going to use this knowledge for the rest of our life. So thank you guys.
Congratulations again, and let's go to our poster sessions to have a more detailed discussions.